What's up, you guys, and welcome to the first ever episode of Sixth Channel at this point. It's because I have 6 channels at this point. Basically, I'm studying for exams, and the best way I learn is hearing the same thing over and over again and teaching myself, or like teaching other people. Let's get right to it. This fluid dynamics problem, fluid mechanics, we got a rotating pump here. So basically the water comes in straight down into this, and then it spins out, and as it's spinning out, it through centripetal force forces the water out of these 2 inlets, which the inlet is pointed like this and like this. What we're given is the volume flow rate for the nozzle, the diameter of this outlet right here, and then the length of each arm, which is 0.52 meters. We're trying to find the rate of rotation, which is actually given, or the answer is supposed to be in RPM. Boom. You already know we're gonna write messy as heck because frick this teacher, and he's gonna get messy handwriting because he's gonna assign stupid problems that no one likes. All right, starting off with the shebang, we got the V-jet volume flow rate of the jets, which is this doohickey right here, is equal to, it's the volume flow rate of the nozzle over 2 pi r squared over 4, but we're gonna write it like this, 2 times pi times r squared, which r squared is actually 0.02, because this is the r of the nozzle, not the radius of the arm here. Squared over 4, bada bing, bada boom. This is in liters per second, and then this is meters of freaking course. Units matter. So we're gonna rewrite this because it's kind of hard to read. So we have V, volume flow rate of nozzle is in liters per second over 2 times pi point, that's a point, 0.02 meters squared over 4. Let's plug in a little bit of values here. We got the 75 liters per second over 2 pi r squared over 4. I happen to know what this value is because I've done it like a million times at this point. Kind of low-key just got that locked in. So our V-jet, volume flow rate jet, gotta remember this is volume flow rate and this is volume flow rate. The dot means it's flow rate, V means it's volume. Volume flow rate of the jet is equal to 119.366. You can double check that with your calculator. I actually didn't round, I just cut off after 3 decimals. So I don't actually, whatever. I think it's a 7 after that, but. And then from the units, we got, well, actually that's not the case, because we also have to multiply this by 1 liter equals 1,000. 1,000 liters equals 1 meter cubed. And this is meters squared here, so we got, that crosses out, and then we have 1 more meter over here. So, and then the liters here cross out because we don't need liters. So this is in meters per second at this point, because originally the volume flow rate of the nozzle is in liters per second, which then we cross out liters, we cross out most of the m's, except for 1, and then we get meters, and then the only other unit is seconds. That's not a 5, that's a second. I don't know why, this is just how you do it. This is how I'm gonna do it on the exam, and I cannot explain why, but basically, the volume, not the volume flow rate, but the volume of the nozzle is equal to the volume flow rate of the jet times cosine of theta. I'm assuming cosine because this is the x, and x is normally cosine, whatever. I have some guesses. Probably doesn't even make sense what I just said. But basically, yeah. And with this cosine of the theta, it gives us a radian value. So it's V nozzle is equal to, we already have this value, 119.366 cosine theta, and I'll put all of the put all the values in the parentheses here. So we got meters per radians. This gives us radians over seconds. This is an E. Next we need W. W, I can't remember what this is. Doesn't matter. Bro, it's finals week. I've been in college way too long. I don't care anymore. So we got this V nozzle, which is this whole value right here, over this R. Now this R is actually this value right here, so 0.52. This is the length of the arm. A little bit different. Pretty sure this has to do with like, it's W, so we call it velocity. It's like angular velocity, so the speed at which something rotates pretty much. Anyway, so our V nozzle is 119.366 cosine, and then I'm pretty sure the angle they want us to have is 30. Get my calculator out. Cosine of 30 degrees, and then M times RAD over S multiplied at the top. And then on the bottom, the R is 0.52 meters, which meters is right here as well, so it crosses out. I know this isn't a fraction over a fraction, but if you put them side by side, this would be on the top and this would be on the bottom, so it cancels out. It's kind of weird math. You kind of have to like be really good at algebra at this point. Anyway, let's do this. So our W is equal to 119.36, we'll put that in a fraction, times cosine of 30 over 0.52 gives us this 198.7861, and this is in radians per second. Always just follow the units. So next up we're solving for n, the rate of rotation, which is n dot. So n is rotation, and then the dot means flow rate. So it's kind of like the flow rate of rotation, which is given in RPM. So we have our n dot equals the W over 2 pi. So that's literally all we do. So this is our 198.786138. You don't need to write all of this. I just like to because I don't know. RAD over seconds, and then 2 pi, which you could just plug into your calculator like this. 2 times pi is 31.6377 equals 31.6377. I write my sevens like this to differentiate them from twos, because sometimes twos can look really messy like that. So if I write a 7 like this, it has the hook here and the dot and the line there. It makes a difference between the 2s and the 7s when you're writing fast. Doesn't really matter. And now this pi doesn't have a value. This is just a number, so it's still radians per second. But if you look up here, we need RPM, which is radians per minute, and this is radians per second. So we have our n dot equals 31.6377 RAD per second. And now if you think about it, we need to keep the radians because we need RPM. So we keep the RAD, which is same there, R, but we need to convert it to minutes. And so if you think about it, we need the seconds on top of our conversion and the minutes on bottom. So 60 seconds, this is also seconds, equals 1 minute. And then the seconds cross out. The only values you're left with is radians and minutes, but you still have to multiply this out. This is technically over 1. So we put this into our calculator, times 60 is equal to 1898.267796. So we get 1898.267796, and we have radians per minute. And so our n dot, which is our final answer, is equal to 1898.2677 RPM. Circle it, we're done.